Right now, the most distant object ever created by humanity is racing into the deep unknown. Almost 50 years ago, Voyager 1 left Earth. Today, it's so far away that a radio signal traveling at the speed of light takes a full day to reach us. But as the probe crosses into interstellar space, its instruments are detecting something strange, a faint, low, monotonous vibration. It is the barely noticeable hum of the cosmic vacuum itself. And the farther Voyager moves from home, the stranger this hum becomes. Our messenger is traveling through space on its mission, awaiting encounters with distant stars that could change its course, or destructive supernova explosions capable of tearing it apart. It's heading toward extreme regions where space itself begins to move faster than light. Voyager will continue traveling long after our oceans dry up, long after our sun dies, and long after the last traces of humanity vanish. But its journey raises a mind-bending question. As Voyager pushes deeper into the vacuum, could it one day reach the very end of space? What happens where the cosmos stops? And what is really hidden inside the strange cosmic hum? If you close your eyes, turn off every device that makes a sound, and imagine absolute, complete nothingness, you still wouldn't feel the loneliness that Voyager 1 is experiencing right now. The spacecraft has traveled so far that the sun now appears as just another bright point, one of thousands scattered across the night sky. Right now, it's 15.8 billion miles from Earth. That's about 170 times farther than the distance between the Earth and the Sun. And the probe continues to race farther away at a speed of nearly 10.5 miles per second, 50 times faster than the speed of sound. At that speed, a commercial airliner could circle the entire Earth in just 40 minutes. For decades, this tremendous speed has carried the probe deeper and deeper into space. But the strangest thing happened the moment Voyager crossed the boundary of the heliosphere, a region of space shaped like a giant teardrop. Inside the heliosphere are streams of charged particles and the solar wind. Beyond its boundary, the sun's influence no longer exists. This line effectively separates interstellar space from our solar system. And after crossing it, Voyager's instruments began detecting dramatic changes. The spacecraft found itself surrounded by a unique interstellar plasma, an extremely thin substance that fills the space between the stars. It contains magnetic fields and faint oscillations that can travel across enormous distances. If the signals from those oscillations are converted into sound, they become that same low, monotonous hum. This environment is very different from the space inside our solar system. It's far more diffuse, far older, and filled with matter that was once ejected by other stars during stellar outbursts and supernova explosions. In fact, this material makes up most of what we call the cosmic vacuum. And for the first time in history, humanity has the opportunity to study this environment directly, rather than simply observing it from afar. Deep space beyond the boundaries of our solar system turned out to be an environment that vibrates on its own, like an endless cosmic rain. Humans will never be able to hear this noise directly, but our probe is literally traveling through it. And the time it takes to deliver this data back to Earth only emphasizes just how far away our spacecraft now is. Right now, it's approaching a symbolic milestone, one light day from home. A command sent to it travels at the speed of light for almost 24 hours, and it takes just as long for the reply to return. To preserve the last remaining drops of energy for this fading connection, NASA engineers are methodically shutting down instruments and support systems, gradually putting the spacecraft into an eternal sleep. Just think about it. One light day after half a century of flight is an unimaginable distance, an entire era. But on the scale of the cosmos, Voyager is still practically next door. Compared to the true size of the observable universe, the distance it's traveled is an unimaginably tiny fraction of its total size. Our most distant messenger is still standing on the doorstep of home, and its real journey is only just beginning. The first thing that awaits us on this journey is a grim paradox. Voyager will not truly leave the solar system until it's already dead. Even though the heliosphere is now behind it, the probe is still under the invisible gravitational pull of the Sun. To escape it completely, the spacecraft must pass through a gigantic icy wall made up of billions of comets at the very edge of our solar system, known as the Oort cloud. Just to reach its outer edge, the spacecraft will need another 300 years. But humanity will never know when it gets there. By around 2030, its plutonium-powered nuclear generator will have completely exhausted its fuel. The probe will shut down forever and continue its journey completely lifeless. It will then take another 30,000 years to pass all the way through the Oort cloud. There is little danger of collision. Space is terrifyingly empty. Even inside the comet cloud, the distances between objects are so enormous that if every comet was shrunk to the size of an ordinary stone, hundreds or even thousands of miles of empty space would separate neighboring stones. Only after escaping the Sun's gravity 40,000 years from now will the lifeless spacecraft make its first close approach to another star, called Gliese 445. It's a dim red dwarf, nearly 3 times smaller and less massive than our Sun. And although the spacecraft will pass at the enormous distance of 1.6 light-years from it, the star's gravity will slightly pull on Voyager, partially altering its future trajectory. A full 40,000 years of travel just to make its first approach to any object along its path. You have to admit, that sounds a little depressing. But only until you realize that what lies ahead of Voyager is no longer tens of thousands, but hundreds of thousands and even millions of years of travel through almost completely empty space, where almost nothing at all will happen around it. Space is not densely packed with worlds the way we often imagine. Between the stars lie terrifying abysses of vacuum. Imagine the Earth was shrunk to the size of a basketball. How far away would the nearest star be on that scale? A mile? 100 miles? Or 1,000? No, about 435,000 miles. In other words, even in this scaled-down universe, the nearest star would be almost twice as far away as the actual distance between the Earth and the Moon. While Earth's oceans evaporate, its atmosphere collapses, and the last traces of humanity disappear. Voyager is destined to keep traveling through this cosmic emptiness. And although that sounds bleak and almost hopeless, we can imagine that in the distant future, our messenger will approach a symbolic milestone, the edge of the Milky Way. And it's here that the greatest disappointment of this truly extraordinary journey becomes especially clear. Our spacecraft will most likely never leave the Milky Way. The probe is permanently bound to its home galaxy by the immense gravity. To understand how this works, imagine that you're standing inside a huge rotating carousel. You wind up and throw a ball straight ahead. From your perspective, the ball moves on its own, flying straight forward. But to an outside observer, the reality is obvious. The entire massive rotating platform continues moving, carrying both you and your throw along with it. Voyager travels in exactly the same way. The spacecraft will continue orbiting the center of the galaxy forever, just as our Sun and hundreds of billions of other stars do. Astronomer Avi Loeb, known for his research on interstellar objects such as Oumuamua and 3I Atlas, together with his colleagues, conducted their own study. Using a detailed model of the mass distribution within the Milky Way, they calculated the long-term trajectories of Voyager 1 and its twin, Voyager 2. Their calculations confirm that even over billions of years, the spacecraft will almost certainly remain gravitationally bound to the galaxy and will not leave the Milky Way. According to their model, over time, the Voyagers will continue moving along their galactic orbits and will eventually end up on the opposite side of the Milky Way's disk relative to the solar system. The only way to escape the galaxy's gravity would be to travel about 30 times faster than Voyager is moving today. And since it has no way to accelerate anymore, its destiny is a closed orbital path, which means only one thing: eternity. But what will physically happen to our traveler after a billion years of orbiting? The space around it may be empty, but it's not completely void of any objects. After a million years, the spacecraft's hull will slowly be damaged by interstellar dust. Microscopic particles traveling at enormous speeds will gradually wear away its outer shell and structure, layer by layer. Only after a billion years will Voyager be damaged enough for the effects to become visually noticeable. There's also the possibility that it could be destroyed by the enormous energy of a nearby supernova explosion. After all, over the course of a billion years, the chance of ending up in the path of such a blast wave is not insignificant. We have a realistic picture of its future. But what if Voyager could ignore gravity and continue flying in a perfectly straight line out of our galaxy? What would it see in that intergalactic abyss? Could it reach the edge of the universe? And what awaits an object that one day arrives where space itself comes to an end? Our solar system seems enormous to us, but it's just one of billions of similar systems in our galaxy. The Milky Way itself stretches across 100,000 light-years, but if we continue moving farther away, we first arrive at our nearest galactic neighborhood, the Local Group. This is a small family of 50 neighboring galaxies dominated by the Milky Way and the giant Andromeda Galaxy. Moving even farther away, we see the Local Group merge with thousands of other systems into the Virgo Supercluster. And it is at this stage that one of the most intriguing mysteries of the cosmos begins to reveal itself. It turns out that all of these thousands of galaxies, including our own, are not scattered through space randomly. We're all racing at an incredible speed of 1.25 million miles per hour toward one specific point. We're being relentlessly pulled toward an object astrophysicists call the Great Attractor. It's a colossal gravitational anomaly, a supermassive cosmic center of gravity whose mass is equivalent to tens of thousands of large galaxies. The most astonishing part is that we cannot observe it directly with telescopes. The Great Attractor is hidden behind the dense, impenetrable clouds of dust and stellar gas within the Milky Way itself. We're blind to it, yet we clearly observe millions of star systems being drawn into this invisible gravitational vortex like beads sliding along invisible strings. The Great Attractor itself is only the inner core of an even larger structure, Laniakea. It is a gigantic supercluster of galaxies resembling a vast cosmic web stretching across 520 million light-years. Our Milky Way is nothing more than a barely visible dot on one distant filament. If we continue even farther, we find that Laniakea itself becomes part of the Sloan Great Wall, a gigantic wall of galaxies stretching for more than 1 billion light-years. But let's continue this journey in our imagination and leave these cosmic walls behind. Once we reach a distance of approximately 16 billion light-years from Earth, we arrive at a truly unique place. If, at that moment, you suddenly decided to turn around, there would be no way back. And not because Earth would have disappeared by then, the path back would physically cease to exist. At this boundary, the expansion of space between you and Earth begins to exceed the speed of light. You've probably heard that physics has an absolute speed limit. No object in the universe can travel faster than the speed of light. That's true, but with one crucial exception. This rule applies only to objects moving through space. It does not apply to space itself. Dark energy causes the cosmic vacuum to expand with constant acceleration. Imagine an ordinary rubber balloon with dots drawn on it using a marker. Those dots are galaxies. As you inflate the balloon, the dots do not move across the rubber by themselves. It is the rubber itself that stretches between them. And the farther apart the dots are, the faster the distance between them increases. At a distance of 16 billion light-years, this process reaches a critical point. The space between us expands so rapidly that the galaxies separating us begin moving away from one another faster than the speed of light. The very fabric of the cosmos is expanding. This is how the cosmological event horizon emerges, an absolute boundary beyond which light from Earth can never make its way back toward us, no matter how long it travels. Right now, there are enormous regions of the universe that humanity has lost forever. On the screens of our telescopes, these distant galaxies will gradually fade, become frozen in time, and disappear forever beyond this invisible edge. It is because of this rapid stretching of the fabric of space that the universe today is much larger than it should be, based on the passage of time alone. Our universe is 13.8 billion years old. At first glance, it would seem that light could have traveled no more than 13.8 billion years in any direction during that time. But if we look at the structure of the entire observable universe, we find that its diameter is a full 98 billion light-years. This is a direct consequence of the rapid expansion of space. But if the universe is expanding at such an enormous rate, then the most important question arises: what exactly is it expanding into? Does the universe have a boundary? And if it doesn't, what could possibly exist beyond it? Right now, we're standing at the very edge of the observable universe. This is the final frontier of space that we can, in principle, know. Before us lies the farthest point from which light has physically had enough time to reach Earth during the entire 13.8 billion year history of our universe. But modern science tells us that beyond this boundary, space does not simply end. Beyond it lies the very same cosmos with its own galaxies, stars, and black holes. We simply never know about them. As we mentioned earlier, ever since the Big Bang, the universe has been expanding continuously, and those vast regions that remain beyond our view are now hidden forever in darkness. But how large is the entire universe if we combine both its observable and hidden regions? Have you ever wondered whether the answer to this question might lie in the shape of the universe itself? After all, the geometry of the universe determines whether it actually has boundaries and what those boundaries might even look like. Modern science suggests that our universe may be described by a closed model. In this concept, all of space curves back onto itself, resembling the surface of an enormous sphere, but one that exists in 4 dimensions. Such a universe has one astonishing property that is extremely difficult for the human mind to grasp. It is finite in volume, yet it has absolutely no edge. Imagine a tiny ant crawling along the surface of a giant globe. It can keep moving forward for an incredibly long time, turn in any direction, and continue its journey forever. Yet it will never find the edge of that world or fall off it. The surface of the globe has a definite limited size, yet it simply has no physical edge. In exactly the same way, our cosmos could be structured. Theoretically, in such a universe, if you boarded a hypothetical starship and kept flying in one direction forever, you would eventually return to the exact same place where your journey began. You would simply travel all the way around the universe, but that is only in theory. In practice, it would of course be impossible. And at this point, another logical question arises. If the universe has no edge, then what exactly is space expanding into? Modern science gives an answer that sounds incredibly strange. It expands into itself. The cosmos does not grow outward, taking over some external realm, nor does it inflate into a larger surrounding space. It does not need anything outside itself. New regions of vacuum are created directly within the cosmos itself, pushing galaxies apart from within and increasing its total volume. This process is driven by dark energy, a completely invisible and still unexplained force that is literally creating space out of nothing before our very eyes. But the closed sphere model is far from the only scenario scientists are considering. There is an opposite, even more bizarre geometry of space, which physicists call an open universe. In this concept, the fabric of the cosmos is curved in a completely different direction, resembling the shape of an endless riding saddle. If the closed universe, despite all its strangeness, at least had a finite volume, then the open universe has no limits at all. It's absolutely, fundamentally infinite. In this model of space, reaching an edge or the end of the journey is impossible, even theoretically. It simply does not exist here. No matter how many billions of years you fly forward, no matter what impossible speed your ship travels at, ahead there will always appear completely new, unexplored space stretching into the deep distance. And this infinite shape of space has its own possible fate. Modern observations show that the expansion of the universe is not slowing down, but on the contrary, it's gradually accelerating under the influence of dark energy. If this process never stops, galaxies will be carried farther and farther away from one another until most of the universe becomes forever unreachable. Over time, star clusters will lose contact with each other. Gradually, the last reserves of hydrogen inside them will burn out. Old stars will fade, and new ones simply will not be able to form. With every billion years, the cosmos will become colder, darker, and emptier, until in this infinite abyss there's nothing left except absolute zero and black holes wandering through total darkness. It's a terrifying but scientifically grounded ending, where the infinity of space turns into infinite loneliness. However, the latest and most precise data from modern space telescopes point to a third and most likely scenario. Science is increasingly leaning toward the idea that our universe is a flat universe. In this model, space is curved neither inward like a sphere nor outward like a saddle. On the largest scales, it has a perfectly flat geometry, where parallel beams of light never intersect or diverge, no matter how many billions of years they travel. And such a universe can also be infinite, just like the open universe. If you boarded a spaceship and decided to fly forward forever, the space ahead of you would never come to an end. New galaxies, star clusters, and extraordinary planets would continue to appear farther and farther ahead, stretching into the distance with not the slightest hint of an ending. But this theory contains an important nuance that continues to trouble astrophysicists. We cannot say with 100% certainty that this flat space is truly infinite. It is entirely possible that our entire observable universe, with all its billions of hidden galaxies, is only a tiny, microscopic fragment of something vastly larger. It's like looking at a perfect, smooth horizon in the middle of the ocean. The water appears flat and endless, but you're simply trapped within the limits of your own view and cannot see the curvature of the planet itself. It's extremely difficult for us to imagine that the universe could be infinite. Any form of infinity contradicts human intuition. It feels natural to us that everything which exists must have boundaries, because in our everyday world, everything has a beginning and an end. But the cosmos may be built in a completely different way. Science allows the possibility that space may continue forever, ending nowhere. And even if the universe is finite, that does not necessarily mean it has an edge in the way we imagine one. In that case, there's most likely no wall of ancient plasma, no giant energy dome, and no boundary separating our universe from something outside it. Because in that case, space would most likely curve back onto itself. Remember the ant crawling across the surface of a globe? It can keep moving forward forever, yet it will never find an edge. And in that case, the universe is no different from that globe, and the ant is no different from us.